Think of the future as being comprised of an infinite number of photos, let's say, where it's a collection of atoms and particles that are configured in various ways, and they're all stored as individual configurations that we can choose from. So, for example, say that this stack of paper here, let's say each paper is different from the paper beneath it by one atom. And so we stack all these papers on top of each other, and we have this stack of paper that we can choose from to create a flow of reality, depending on which atoms we need to change from moment to moment. And let's say that these papers have a dimension of length and depth, but let's say they have no dimension of width. So this piece of paper here has no dimension in this direction, up and down. There's no dimension. It's only length and depth. That means that if we take a whole stack of these papers and each paper has no dimension of width, we could move all these papers into a dimension that would be would have the same width as a single piece of paper. So we could have a infinite stack of pages in a stack and collapse them all down to the same width as a single page. And because that page has no width, there's no width. No matter how many, an infinite number of pages are compressed, you can compress them down to a width of 0. So no matter how many individual pages you're collapsing, you can collapse an infinite number of them down into the same instant. So if we think of the future as being comprised of an infinite number of pages or pictures, let's say pictures, there can be an infinite number of pictures in the future. They don't move, they don't flow, they're just there to pick from, like paint pictures on a wall. And you can pick which pictures on the wall you want to combine together to create a superimposed picture comprised of all the individual pictures. So, and the other thing is, if you think of this paper, nothing can move up or down. They can just move within the plane of the paper. So even though there's an infinite number of pages all stacked together within the same instant, they cannot interact with each other because they can only move lengthwise and depthwise. But anything that exists within this page cannot move up or down between other pages. So they're isolated, even though they're all occupying the same instant in time. And so I guess when you collapse all these pages, you select some pages out of all these possible selections and combine them together into a superposition and collapse them down into the same instant, that would create what we call the present moment. Then you take that superposition of all possibilities and add them onto other moments that have been superpositioned into previous moments, and that creates a history. So let's say from here up we have the future, and this moment right here is the present, and then here down is the past, and here's our observer. So in the future you have an infinite number of individual pictures. They're not moving, they're not flowing, they're just hanging there on the wall, let's say. So that's the future. So it's discrete because it's each individual picture. It's quantum because each one is separable and individual and definable as an individual picture. It has a probability wave because you don't know which picture you're going to combine to the other pictures to create a superposition in the present. And so it's unknowable because we cannot see into the future. We only can remember the past, but we cannot foresee the future. So these individual pictures in the present will be selected. Individual pictures will be selected. Maybe, let's say you select 4 pictures out of an infinite stack of pictures. You select 4. They collapse down here in the present into a stack and into a superposition, or a stack of just 4 papers, which are superpositioned into themselves in the present, and then the present gets added to the previous superposition, which is added to the previous, and on until the day you were born. So if we call T0 the time at which you were born, and then each moment in time continues until the time in the present, then you go from like T0 to Tn, which is the time in the present, and all the time in between. So these are like pictures, discrete and individual, that you can select from. And that's quantum physics. Then you have the present, where all of the selected pictures collapse down into the present, where you create a moment in the present, which is the collapse of the probability wave. Not knowing which picture you will select creates a probability wave because you're not sure what the collapsed configuration of the pictures will look like. So, but there's a probability that you will select some more likely than others. So it creates this probability wave of pictures that will be selected more likely than other pictures. Once those pictures are selected and collapsed into the present, then we have the collapse of the probability wave. That superposition gets added to the past, and this is like a film now. They're connected. You got each moment is connected, and it runs like a film. So this part is continuous. This part is discrete. This part is like the Newtonian type physics, where you can make predictable calculations about like trajectory and momentum and velocity and things like that, because all the moments are connected. And it's predictable and it's knowable because it's our history, it's the things we remember. And so you have, this is our memory. So this is our future, which we don't know. This is the present, which converts the future into the past. And this is our timeline of history that remains knowable to us. And so, knowable to it. And so that's it. And so, if we replace pictures with parallel universes, and all the parallel universes are composed of positrons, and then this is us existing in our universe, and we're composed of electrons, then the negative charge of the electron and the positive charge of the positrons will be an attractive force. So when the wave function collapses, when the probability wave collapses down and creates a superposition, then the positive charge will be of the collapsed superposition universes of antimatter will be attracted towards the positive charge of our universe. And so in the known universe, the whole universe is as big as we think it is, the scientists think there's about 6 times 10 to the 8 power bits of information contained within the known universe. And of that, about 11 million bits of information are available to us in the observable universe. And out of that, about 50 bits of information become part of our consciousness. So when the wave collapses and the positrons and the electrons are attracted towards each other in the present, then the electrons from our universe will transition into photons. And if the electromagnetic field is consistent and doesn't change, under transformation, then this cyclical transition can be maintained. So if you have the magnetic field in the Y dimension and the electromagnetic field, I should say, in the Z direction, then as you rotate in the direction of velocity to which you're moving through space, then if we rotate the electron out of the dimension of space in the direction you're traveling and into the dimension of time, then the electron is no longer perpendicular to the electromagnetic field, and so the electric charge goes to 0. So, but the spins will remain unchanged, and they'll add. So you'll have the 1/2 spin of the electron and the 1/2 spin of the well, actually you'll have the 1/2 spin of the electron and will combine with the 1/2 spin of another electron, and they'll add together and they'll lose their charge and they'll become a photon. And then the photon will rotate into the Higgs field and become a graviton, and then the reverse will happen until you arrive in the parallel universe as a positron. So you're able to transition from an electron to a positron from our universe into the parallel universe, as long as the electromagnetic field remains invariant under transition. And so when two electrons combine to create a photon in our universe, some of the photons will transform into gravitons, back into photons and into positrons, and they'll become stored, or they'll continue the cycle here. At this point, some of these photons are from our universe, and some of these photons are from the parallel universes. And they'll when we store our consciousness into our memory and in the matter of electrons, at that moment the collapsed wave function will separate, and all the superposition universes will expand back out into separate universes. Each of these universes contain about 11 megabits of information each, not information, but bits, 11 megabits each. So, these are all separate parallel universes that contain, because that's all you need. They don't need to have the full 6 times 10 to the 80th power, because we can only process 11 million bits of that total number. So all we really need is 11 million bits of information in each possible universe when they collapse. And so the information hitting us from photons and fermions will be about 11 million bits of information And then that 11 billion bits of information, which is represented here in the form of photons and electrons, will combine with the superposition of 11 million bits of information in the parallel universe right here. Some of these photons will get stored back into the superpositioned universe. Some of the positrons will get stored back into the superpositioned universe, and some of them will convert into electrons, which will get converted back into photons, which some will get stored into our consciousness or into our universe. Some will continue on and become positrons and get stored. So in the end, our history, our consciousness will be comprised of both information from both universes, from our universe and from any number of these parallel universes that were involved in the collapse of the wave function into a superposition. So we will contain a history of just 50 bits of information. So whereas each of these is 11 megabits of information, each of these is just 50 bits of information, because that's how much information our consciousness can store. And our history will begin at our date of birth and continue to the present, and the future will continue from the present into infinity. And so that's how an observer can become aware of events that happened in the observable universe in which the observer lives, and events in parallel universes that, if you think of all these universes being at the same place in space, but parallel, then all of the events that happened at this point in space and all of the universes are accessible to the observer. It just depends on which bits of information get captured by the observer, which bits of information get stored back into the observer's universe within his observable universe, and how many bits of information get stored back into the bits of information in the parallel universe within these 11 million 11 megabits of information. And that's it.